Do it.
Do it now. You can do it.
So now if you plug a 0 in, so each one of these inputs represents a problem in itself. So there's the first problem. The second problem is plug a 0 in for x. Twice 0, 0. For some reason, I get people having the 2 stay alive. That 0 kills it. So y is -3. So the output for 0 is -3. Third little mini problem. You plug a 1 in for x. Now 2 times 1 is 2. -3, -1. And the fourth little mini problem. Plug a 2 in for x. 4 minus 3, 1. So now I have these points. Just graph them, and they should line up in a straight line. And notice something really interesting. This number here is 2. That's crazy. Every time I change x, y should change by twice as much. Because this y is basically 2x. The whole thing's down 3. But you guys, that number 2 is important. And notice here, when x went up from 0 to 1, how much did y change? When x went from 1 to 2, y changed 2 again. So if I would have put a 3 there, I would have seen them changing by 3 every time.
Oh, that's the formula.
Oh, dude. Some of you guys might remember possibly ever seeing mx plus 1. Maybe it's been forgotten. But Math 90, Math 103, 110 will definitely be getting a lot deeper into these. Right now, we're just doing the basics, but I want to show you why it kind of makes sense that this number tells me how quickly it's going to go up or down if it was negative.
Yeah, because it was negative.
Exactly. That would mean that every time x changed, y would go down by some more amount. Yeah. So here I got -1. -1, -5. 0, -3. So again, back 1, down 5. The x is always left and right. The y is always up and down. Don't go anywhere left and right, but go down 3. Is that cool so far? Obviously, you can't graph a line if you can't graph a point. So this is a very basic skill for graphing equations, is just finding each of these points. 1, -1. So go 1 over on the x-axis and -1. So down 1 on the y-axis. Okay. A lot of you guys are still looking at me like crazy. So whenever you look at a map and they have like, this street is in H5. That means you go over to H, down to 5, and then you find the street in that little block. You with me? This is basically the same idea. 2, 1. So that means, yeah, 2 to the right, 1 up. So 2 to the right, 1 up. So now, when you do this, then I can just look at the graph then and say, when x is 2, what's y? When x is 2, y is 1. You can see that. That's what that point represents. And do they make a straight line? Yes, straight enough for a person drawing it. Considering it's me, that's pretty damn straight. Good. And the really nice thing about this, and now of course the more precise you make your line, the more answers you can give me without having to do the work. So whatever point this is, works in this equation. Whatever point that is, works in that equation, so forth. So again, this is the quickest way to answer. This is a beautiful idea. That's a visual representation of all the answers to this. Because how many answers are there? Infinitely many. Hell, there are infinitely many answers between those two. You guys realize that? How many numbers are between 0 and 1? Infinitely many. Because there's 0.1, 0.11, 0.111, 0.11111, 0.111. That itself would go forever. You guys kind of... So what's the quickest way? If somebody says, what's all the answers to this? I ain't going to list them. I'm going to give them a freaking picture and say, you go find whatever answer you want. Yeah, right.
You get -5 out of that.
So when you plug in a -1, plug a -1 in for x to the equation. Twice -1. It's -2. -3. -5. So when you take the equation y equals 2x minus 3. And if I say if x is negative 1, right, that's what this is saying right there. So that was given to us, right? If x is negative 1, this is blank. So I got to figure out what's y if x is negative 1. If x is 0, what's y? If x is 1, what's y? That's my job when I'm given a table of values to fill out. So then you plug in negative 1. And this is where you got to remember your order operations. For some reason, all of a sudden, order operations goes out the door when we get here. But it still exists. You've got to multiply there first. And that's, of course, where that negative 5 comes from. So,
I see that part right there.
all right,
For some reason, I'm not, still not registering.
we'll do some more.
All right.
But at each step, I did the same thing. So on this one, now where did I get these numbers from? These are the numbers I normally use when I'm going to graph a line. I normally start with these. I don't want to plug 18 billion in there. I could, but I don't want to graph that far over. Right? So I'm going to stick around 0, some negatives, some positives. You guys kind of with me? So not everything in the world is a straight line. So later when you start doing curves, and real quick, the reason this is a straight line is because all the variables have a first power. Are you guys semi-still? The minute that I have like y equals x squared, the minute that a variable does not have a first power, it's got some other power on it, any other power, you're going to have some kind of a curve. That's in your future. We're not going to do curves in here. We're just sticking with lines. Okay, let's do another one.
I think what it was is that I was actually taking 2x minus 3, and I was solving that.
Oh, we're trying to set it equal to this or something maybe.
I was just trying.
I got
I was
you.
just solving it, and
Gotcha.
okay.
So let's do another one. Let me leave that up here. So what values do you want to try for x?
2, 3, 4, 5.
I like it.
You always be mean and give us y.
It's not a bad idea to always include 0.
0, 2, 3, 4.
I like it. And then what the hell? We'll go there. We'll do these 4 here. I like it. And this is a straight line, so it doesn't matter as much. But when you go further and you start getting more advanced stuff, you want to include negatives, positives. You almost always want to include 0 because that's kind of like considered to be where it starts in a way. It's on this axis and it kind of goes from there in both directions. So these are 4 little mini problems.
I realized we did it.
So here again, just to do the first little mini problem, what are you plugging in for x? 0. And then negative 3 times 0. 0 plus 4. So you get the first point should be 0, 4. So you guys finish that out real quick. Alright. It's the most exciting thing in the world, watching somebody make a graph. Here we go. So how do you do the second little problem here? Yeah, so you have negative 3 times x, but in this case x will be 2. Negative 3 times 2 is
Negative 6.
negative 6. Negative 6 plus 4, negative 2. Do the third little problem. Put a 3 in there. Negative 3 times 3, negative 9. Plus 4, negative 5. I like it. And then do the fourth little problem. Plug a 4 in. Negative 3 times 4, negative 12. Negative 12 plus 4, negative 8. And now you see why I did that. How you guys feel about just that part right there? I mean, some of the homework problems are going to be just this. And they sometimes give you x, and they sometimes also give you y, and then you would just plug in for y and solve for x. Whatever variable they give you a value for, you plug that in and you solve for the other. Most often we consider x to be the input and y to be the output. Obviously, especially when it's solved for y already. When y is by itself, you plug a number in for x, y will pop right out of there. This is very often considered the input. So that's considered the output. My only good marker is blue. So what points do we have the graph? 0, 4. So that tells me to do, yeah, this says don't go anywhere over left and right, but do go up 4. This tells me to over 2, and then 2 down. Over 3,
Down 5.
down 5. Over 3, down 5. And then over 4, down 8. Holy
Mike, there you go again.
Yeah, I know.
Okay, what teacher's over there?
They guys mad or something?
They got something against you?
I don't know, to tell you honestly. I just randomly piss people off, I guess. I remind somebody of their
Parked
own
too close to
math.
somebody in that staff parking lot, didn't you?
Yeah. Exactly. Alright, so is that cool? Notice something real quick. From 2 to 3, x changed by 1. How much did y change? It went down 3. And look, this graph is pointing up. That graph is pointing down. This had a positive 2 here. This has a negative 3 there. Interesting. So every time x changes by 1, y changes by 3 down. So look here, x changed by 2. Y changed by 6 down. From 4 to 0 is 4, then 2 more down is 6, so 1, 6 down. It makes sense. For every step in the x direction, it goes down 3. 2 steps over is down 6, so forth.
And then down, it's the other
Just thinking.
so, like number 2, like down 6, that's the answer, the negative 3 times 2.
True. Yeah, you gotta be careful though. That's
Not always the case.
not always the case.
I just see a pen.
Alright, so notice I kind of left out a point 1 something here, right? So it should capture it on my graph if only my graph were a little better. Let's pretend like my graph is a little better. So if I plug a 1 in, what do I get out? Negative 3 times 1 is negative 3 plus 4.
Negative 1.
Negative 3 plus 4.
I mean,
Positive.
1 whole 1, sorry.
Yeah. So my scale, of course, sucked a little bit. But the more precise you are, the more you can capture intermediate answers. That's why for a line, you only need really 3 points. You only need 2 points to make any line, but the third point is to kind of check yourself. Now I'm doing 4 just for extra practice right here. How do we feel about that? Is that decent? So just to push it a little bit. I want to show you an example from your future. If I say that, it sounds weird.
Hop in our DeLorean.
That's exactly what I'm thinking. It's Michael J. Fox has a new show, a new television show coming out. The trailer's out. I saw it yesterday. It looks like it's going to be pretty good. But what if I had this here? What if you did, Jeff? I do it the same way. I said now, like I said earlier, is this going to be a straight line? No. I'm going a little bit beyond our current curriculum, but I just want to. I always do that because I want to show you how this idea extends. So I want to plug in some negatives, definitely 0, and some positives, just to get a feel for what's going on. We can all do this. We know how to square stuff. Yes, you do.
I was like,
Damn, great.
Alright, I gotta stick with it. So here we got little problem number 1. I plug in what for x? -2. And what's -2 squared? Careful.
Positive 4. We're all yawning.
So then 4 minus 3?
1.
1.
The whole kind, not the negative kind.
And then little problem number 2, plug in a -1.
1.
Yeah. So positive 1 minus 3? -2. Are you guys with me so far? I mean, the idea that we applied with lines applies to any function. You make an XY table, you get a bunch of points, and you plot them. It's just that the freakier your function gets, the more points you're going to want, because it might be turning all over the damn place. And if you don't put enough points in, you don't know where it's turning. Yeah.
Just to refresh, when multiplying, if you have a number that's a negative, the answer is automatically going to be negative, no matter if it's greater or smaller, or...
Oh, so give me an example of what you're talking about. Like if I'm doing -2
Yeah.
times 4?
Yeah.
Yeah, exactly. There's 1, so that's 8. So that's -8.
Just because it's a negative in the numbers overall, right? Okay.
Yep.
I just...
It's only if there's an even number of negatives that it would cancel.
Okay.
That's why anything squared will come out positive, because if it's negative, you get 2 of them. So that's -2 times -2 is positive 4. Cool. What about when I plug a 0 in? Yeah, exactly. 0 squared is nothing, so you end up with -3. Now the funky thing about plugging 1 in, what's going to happen when I plug 1 in? It'll be the exact same thing I got here, won't it? What's -1 squared?
Positive 1.
Positive 1. And what's positive 1 squared?
Plus 1.
Positive 1. So I get the same answer. So if you want to do the work, plug a 1 in for x. Plug a 1 in for x. -3. Sure enough, you get positive 1 minus 3. Same answer.
Parabola already, Romeo?
This is a parabola we're doing right here.
You will get the same answer at the bottom too.
Exactly. 2 will be the same thing as this. So when you plug in a 2, I need some room for this. Crap. When you plug in a 2, 2 squared is 4, minus 3, 1. So what the hell is this thing going to look like?
Look at U-shape.
U-shape. I like U-shape. So let's see now. I can plot the point. -2, 1. That tells me to go.
Down 2.
Careful.
Oh, back to
Yeah, left 2,
Up 1.
up 1.
Left,
Yeah, so it's always X, left and right, Y up and down. This has to go
left 1, down
good.
2.
Left 1, down 2.
Stay there, go down.
Don't go anywhere left and right. Go down 3.
Go to the right, 1 up. Oh, wow.
1 over,
Down 2.
down 2. And then 2 over, up 1. And see the mirror image going on? There's your parabola. Right. So a parabola is that big of a deal? No. think is the most important point, in a way, on that parabola?
The zero.
Yeah, we call it that guy right there.
Vertex.
It's called the vertex. I like it. Do you have to know that for this class? No? But there it is. And that very often is the most important point, because this might be, well, very often in the real world we get these upside down parabolas. And this is our profit for a company. And we're here, and the boss is like, I want to be there, Johnson. Get us over there. So this is the graph of how much do I set the price at, and at some point I'm going to get the most profit. Because if I make it too high, nobody's going to buy the damn thing. And if I make it too low, I'm not making enough money. So somewhere there's that sweet spot. And very often they come out to be, if not truly X squares, they still have parts that look like this. So you're always trying to kind of move yourself up there. The funky thing is, the reason these people get paid so much money, the people that do this work, the financial advisors, is because this whole thing is always moving around. So you're trying to get here, and you get there, and then suddenly the peak's moved over somewhere else because demand is changing, price of gas is changing, so the amount of money it costs to get your materials to your factory has changed, and all this stuff has changed. So financial advisors are always changing all those variables, seeing where the new peak is and trying to move you there. That's at least part of their job anyway. So I could have made a lot of money doing that, and I realized it would have driven me completely insane. So I signed up.
What's the formula for that?
What's that?
What's the point?
Oh, for this, what do you think? This one's opening up because this is positive. If I would have made this negative, it would have opened down. And then it could have been an equation for like throwing a baseball at somebody. Right? Takes that arc like that. So baseball basically follows an upside down parabola. Yeah, it's kind of... Okay. So how's that? Before we get into chapter 9, anything lingering from chapter 8? So it's just really plotting points, completing XY tables, and then plotting functions. You're not going to see one of these. Right? This is just me going a little further like I always do. But you'll definitely see lines. Oh, some special cases before I leave this. So do you see how when we did this equation, when x changes, y is definitely going to change? Because y is related to x. You guys with me? So when x changes, the value of y is going to change. So what if I get an equation like this then? So instead of negative 3x plus 4, I get y equals 4.
Plug it in.
Now, when x changes, does y care? What is y? Y is always 4. Careful, get the right idea, wrong direction. So what's got to be true about our points then? Here's the funky thing. What's all going to be up and down here?
4.
What is y always?
4.
So, for example, when x is 0, what's y?
4.
And do you guys understand? Because what is this equation? Does it have any restriction on x? No, there's no x in here. Y is always 4. So x could be whatever it wants to be. Y will be 4. All right? So how do you graph this damn thing? Well, you start, when x is 0, y must be 4. When x is 1, 4. When x is negative 1, 4. So it looks like that. So think about it. If y has to stay the same, and what does y tell me? X tells me how much to go left and right. Y tells me how much to go. So if y has to stay the same, it cannot go up and down. It has to go. So what the hell would x equals 4 look like?
Up and down, straight.
It would look like up and down because now it can't move left and right. X equals 4 would look like that. X must be 4. It cannot deviate, but y can be all that it wants to be. Those are special cases. Those are always kind of weird. All right? People have trouble when they try to force them to work like these do or like the other ones do. They don't work like these. They're special cases. Cool. Okay, how do you feel about that? There will be some of those in the homework. Oh, yeah. Okay,
Fun
so
times.
I think I was considering doing this I want to cut down on the section, on the chapter 9 homework a little bit. Because I got a little overzealous when I did this. But I'll do this instead. What currently is the homework for section 9.3? Somebody, I think it goes up to 36. It's extra credit, don't worry. So section 9.3, you can stop at number 24. Anything past that is extra credit. I just want to focus on areas. You guys will talk more about volumes later. So let's talk about areas for a little bit. And guys, I don't know if you realize this, but today's our last day of new stuff. We've reached the end of the homework sheet. It feels like just yesterday I was talking about the syllabus. It's crazy. So there are certainly some area formulas we already know. For example, the area of a rectangle.
Base times. Or length times width.
Length times width. What's the area of a triangle?
1/2 base times height.
Good. Guys with me so far? Because of course any triangle is just half of some associated rectangle. Parallelogram, we won't get into it. But basically that's the idea, it's half of this kind of shape. So it's got to be half of that area formula. Does that make sense? Alright, so let me ask you some freaky questions to get us in the next
How do
level.
we know when to use that formula versus the, what is it, the A equals B squared plus C squared or something?
That's the
Oh,
perimeter.
careful.
It's fine, the length not big.
That's the
One
perimeter.
side
Yeah,
more?
this is for the sides of a right triangle. That's a good question.
Oh, okay.
That's for the sides of a right triangle. This one is for the area of that triangle. This one would find the lengths of the sides
Okay.
of a right triangle.
Okay.
This one would find the area of actually any triangle. Now let me be very clear here. This height, so I mean, if I was, if there was a building, well, the Leaning Tower piece. So if I said how high is that, how high is it? You wouldn't measure this height. That's how tall it would be if the damn thing was standing upright, right? How high is it is actually, how high is it straight up from the ground? So it's got to be at that right angle to the ground. So if I had a triangle like this, oh yeah. If I had a triangle like this, let's say that's 4, 7, 8. I don't have enough information to find the area. Because where is what's the base? 8. So we know the base is 8. What's the height?
We don't know yet.
Don't know. They haven't told me yet. So I have to come in and tell you, okay, that height is 3. So I have to give you the true height. The height is always measured straight up from the ground. It can't be some slant height. It's got to be straight up. So now what would the area of this triangle be? 1/2
4 times 3.
times 8 times 3, 11. So 4 times 3, 12. Yeah, 4 times 3, yeah. Let's say this is inches, then it would be inches squared. Why the hell is it square inches?
Because it's a three-dimensional number.
This area.
Because what is 8 what? 8 inches, 3 inches, and what's inch times inch?
Square.
Inch squared. It's really that simple. Of course, when you try to cover something, how many dimensions you have to do? You have to go left and right, up and down. You got to cover 2 dimensions. So that's why it's 2-dimensional. If I want to fill the room up, I then have to go this way, and up. That's 3. Volume would be in cubic units. I could fill this room with little cubes. I could cover the floor with little squares. That's why that's squared. Volume would be cubed. You guys got it with me? So be real careful when you give me the units on area. It's got to be squared. Because you are multiplying that unit by itself. That would be squared. So here's the next step. Here's the next level. I'm going to ask you some strange questions real quick. It's not too strange, but it'll look strange for a second. Bless you. Wait a minute. Okay, those are freaky looking
So you made it a right triangle.
triangles.
And then after I drew it, you changed it.
I know, I do these things. I did it just to throw you guys off. The area of this triangle would be what? Now stay with me, this has a purpose.
Half times base times height.
Yeah, be more specific. Half times
Oh,
B1 times H, right? So it's 1/2 B1H. Cool. What about that one? It's turned it upside down, but it's still the same formula. The area of this triangle would be 1/2 B2
B2
times H. Now, if I were to slap these things together, I would make trapezoid. Trapezoid is defined to be two sides of parallel. Oh, I'm sorry. Stole your thunder. So trapezoid, the last two sides can do whatever they want to, really. To be an official kind of trapezoid, you need the last two sides to not be parallel, or else you become a rectangle, right? But these two sides have to be parallel. These can do whatever they want to. So this one's kind of weird. It looks like a triangle that's got its head cut off. But what we just did was, here's that triangle right there. And what was its area? 1/2 B1H. Here's that triangle right there. Its area was 1/2 B2H. So here's H, here's B2, here's B1. You guys semi-see what I'm trying to do for you? I want to show you where this formula came from. So any trapezoid, if I give you a trapezoid, you could cut it into two triangles. Find the areas and add them together. But now I have a more general formula for the trapezoid itself. The trapezoid's area will be this area plus that area. You guys, all right, cool. If you draw any trapezoid you want to, I can always just draw that dotted line in and make two triangles. You can find the area of both those triangles, which we actually did before you knew why I was doing it. Then you add those two areas together to get the whole area of the trapezoid. You with me? So I add those two areas we got that were really simple, because they're just little triangles. Add those together. And then the last step was a little bit freaky, but let me see if you guys are cool with it. We all know distributive property. So I'm going to do it in the opposite direction. I'm going to take that 1/2 back out and that H back out. So it's like I took it back out from the B1 and from the B2. I took it back out. If you were to distribute that through, wouldn't you get this back and that back? So I don't know if you guys have ever seen this, but that's the area of a trapezoid. It looks like a triangle had its head cut off. So it's still 1/2 the base times the height, but now there's two bases. This base and that base. So you just use both of them in there to be fair. So if you see, so for example,
one of the books says 1/2 B1 plus B2 times H.
All right, so if I say 4 times 3 and you say 4 times 4,
It's the same.
Which one's
but
right? Okay.
I know. I'm just saying. I'm just saying that some people might get confused by that because that's what it says on the page.
I understand. But yeah, all you need is all these parts. The sum of the bases times the height, and then half of that. So let's do a concrete example. If I had this trapezoid here, what would its area be?
Is it
40.
1/2
Or 45.
little base times
It'll be 1/2.
little base
Yeah, the sum of the bases. So you add the bases up
times the height?
times the height. I like it. 1/2
18.
18. Half of 18 is
9,
9 times 5,
45.
45. I love it. So there's a level of where the hell did the formula come from? And then there's a level of can you just plug and chug and use the formula? So I'm always going to show you where something came from. Are you ever going to have to do that yourself? Am I going to give you a shape and say, come up with the general equation for... No, I'm not going to do that shit to you. But I do always want to show you where the formulas that we use came from. Alright, how you guys feel about that? Have you ever seen that formula before for the trapezoid? Does it sound familiar at all? No? Okay, well there you go.
It's just been a while.
Maybe you have, and yeah, I got you. Now, one of the coolest things to me, and I say to me because it might just be me, but did you guys pick up the idea that when I get a shape that I don't know the formula for, I try to cut it into shapes that I do know? That kind of makes sense, because then I can just add them all together. So something we can do that with that's kind of freaky that we can do it with that is a circle. We can do the same thing with the circle to figure out its area. Not many people have seen what I'm about to show you. Sounds a little freaky, but that's all right. One day I will actually bring construction paper and do this, but that day is not today. Let me get you guys to help me out. First off, do you guys remember the circumference of a circle? Good, it's all the way around. And what's the formula for that?
2 times pi radius or something.
I like it, 2 pi r. Does that sound at all familiar?
It's starting to.
Sort of? Okay. So we've got this idea. What's this if I draw it in? What's that?
Diameter.
Good, that's diameter. And of course, if I go,
Half its radius.
good, halfway is radius. Cool. So here's what we can do with this circle that's kind of nifty. And one day I'll actually do it with real paper, but again, not today. If I cut this circle right down the middle, just cut it right down the middle. So now I've got this part and that part. Okay, that's a little extreme, Jeff, the rest of it. And then I take it from the center. Now just go with me. Just imagine what's going on here. If I take it from the center and cut out to the edges, but I don't cut through the edge, I cut out to the edges, like that. And then open it up. Are you guys kind of with me? So I cut out, but I don't cut all the way through. And then I open it up, it would look like teeth. Right? There it is.
Now you're just getting crazy.
Sing it.
I said, now you're just getting crazy.
I know, it's crazy.
Now he's making a bunch of triangles.
Now, yes sir.
But then if you do the same thing at the bottom,
It'll fit it?
it's a
I love it.
square, or a rectangle.
Now be careful. Now help me out. If all the way around is 2 pi r, what's halfway around? Yeah, pi r, right? Half of 2 pi r. So if I open it up, this pi r must be this. You guys still with me? So if I open it up for the teeth, that's pi r. Well, it's still got to be freaking pi r. Just because I open it up, it's not going to change. And how big is this? What's this?
Radius.
From the center out is the radius. I love it. So if I fit the other teeth in, if I do the same thing with the bottom part and fit it in, be like that, base roughly. And this is making a rectangle. This is a rectangle now. And if I made the cuts, if I made my teeth even sharper, made my cuts even better, it would become more and more better, like a true rectangle. And what would the area of this rectangle be? Length times width. Pi r times r. What's r times r? So there's the area of a circle. Pi r squared. Now, a lot of you guys already knew that. Has anybody ever seen that? I love this thing. And someday I'll do the visual, because the visual would probably be a little bit better than me just drawing it and making hand motions. But it's really a neat idea. It's the same idea as what we did here. You try to take a shape you don't know, you cut it into a shape you do know, and you work with that shape. That, to me, is really, really cool. I still remember the first time I saw that. It's like, Kick ass. So that's the area of a circle. So if I had a circle like this, here's where you got to be a little careful. So if the area is in general pi r squared, what do I not really know yet? I don't know r.
Well, so 30 by half 6.
Exactly. So now I know r.
So pi times 36.
R is 6. So be careful if they give you the diameter, don't put 12 in there, you gotta put half of that. So it'll be pi times 6 squared. Like John said, 6 squared is 36. And then you can plug this into your calculator. Hopefully, most of you guys have a pi button. If you don't, what can you use to be close?
3.14.
Yeah, 3.14.
Which also
But you should probably have a pi button. If you take a look at your calculator, somewhere there's a little pi symbol. If you have a scientific calculator, it should be on there. Yeah. Oh, you got your dedicated pi. I like it. Some of you guys might have it sitting above another button. What do you guys get when you do 36 times pi?
113.
You get pi. Just do it again, I'm sorry.
113.09733559.
Yours went out farther than mine did.
What would the units be?
Feet squared.
Good. Square feet. I like it. Yes, ma'am.
When I put it on my calculator, I get like an answer and pi at the end. So how do I choose that?
Oh, that's neat.
Nice.
So you probably have.
I need to like start keeping it.
There.
I needed it yesterday. I don't want to use it.
So you have like another mode. See how the last one says classic? It goes under Mac Pro. So classic will just, I guess it won't show the symbol. It'll use this.
3.14 is pi.
Yeah.
Oh, so you got okay.
Oh, yeah, that's what I have.
All right. Has everybody got that?
Everybody has trouble remembering it. It's literally.
I was just wondering where this is going. Yeah, I was doing the same thing.
Decimal, right?
Yeah, if this was 11, I'd still have to use half of 11 for radius. Yeah, whatever number that is. Exactly. And we can all handle that. So I will definitely give you fractional diameters, decimal diameters. Yeah, I could say this is 8/5 of a foot. Find the area. I could do that. I could be that evil. Right. That's not even that evil, really. Just there.
So when I like 6 with the pi, it gave me the current number.
Yep, that's fine.
So 6 times 5
Equals. So it just showed you the 3.14 for pi. Yeah, good.
Okay.
Some of you guys gotta be careful when you hit the pi button. It shows you what pi is. You have to hit equals to make it do the operation. Yeah. Cool. All right. And just to show you one thing from the volumes. Oh, they do show you this. Oh, cool. Bottom of page 617. I hadn't even looked at this section yet, but they do exactly the T thing. I had never seen that in a book before. That is cool. Now, I really appreciate that. Yeah. But let me show you one thing from volume, and then I'll let you guys head out. You didn't get the practice test, by the way. You probably want to get that from you before you leave. Here's a shape that we see a lot of the times. This is a cylinder. Very often you'll see this shape used actually on farms, for example, on to keep grain and peanuts and so forth. Because this circular shape will hold more stuff for less material outside. If you made this like a block, like made this more like this, Not only would it fall over from obvious structural difficulties, but you wouldn't be able to fit as much stuff in. You have to have more material for the same amount of stuff to fit in. So that's why you see this shape very often holding grain and stuff like that, because it actually lets you put more stuff in for less material, which of course costs money, so you want to save some money. So the question right now is, what the hell would the volume of this thing be?
It says pi r squared h.
Yeah, don't look at what that says. We're going to build up to that point. Do you guys see how, the way I kind of look at this is it's a bunch of pennies stacked up, for example? I see a penny there, and there's a penny on top of that, and a penny, penny, penny. So if I knew the area of one of the pennies, and I knew how tall the stack was, I could multiply the area of one penny times the height. That should give me the volume that goes through. So what is the area of the base? What shape is the base? Circle. So what is the area of that base? Pi r squared. I love it. We just talked about that one. And the height is, incredibly enough, h. So if I take the area of the bottom times how tall it is, how many pennies I've got stacked up, that should equal the volume that the thing goes through. So if I take pi r squared, how much area is on the bottom, times how many of these I got stacked up, which is h. That's going to be the volume, pi r squared h. It's kind of a neat idea, too. The area of the base times how tall the thing is, that's the volume. And that's the most I'll say about volume. So if you need the practice test, you should probably want to pick that up on the way out. So next time I'll have the answer key and I'll have these quizzes graded. Yep.
Are we having a test on Thursday?
Thursday's review day.